Hi, Year 12. I'm going to talk a little bit more about the properties of logarithms, and we're also going to look at the graph of a logarithmic function. So following on from our introduction to what logarithms are, I'm going to talk firstly about the common bases that we tend to use. And seeing as you now know about e as well, we're going to add that to our list of logarithms too. So I'm going to write common bases. This goes into some notation that we use that you need to be familiar with. So typically log base 2 of whatever, okay? That's quite common because particularly when you're doing computer science, you come across powers of 2, particularly like things like binary, that kind of thing. So that's quite common. Log base 10, I think I've said in another video, that's common as well. Because our decimal number system works on powers of 10, that means that log base 10 is common as well when we're talking about things like how many digits a certain value has. It measures the size of numbers. So that's common. It's called the common base. And just like when you've got a square root and you don't write the 2 next to the square root, we tend to omit the 10 when we're using base 10. So this is equivalent to saying just log as the word log. Okay, so when you see this, it's implied that it's base 10. And then finally, seeing as we now are familiar with e to the x, it's incredibly common to see log base e. And the notation we use for that, which you saw probably in the 3 blue 1 brown video, is ln. Okay, don't ask me why. This is the notation for the natural log. And it's log base e. So what power of e is this? Okay, it's important that you know it's called natural log. I'll write it down. Okay, it's written ln. You typically say ln of and then the number. So ln of 4, ln of 10, that kind of thing. All right, even though it sounds a bit strange. So keeping those in mind, we're going to look at the graphs of these things. Okay, so I'm going to start with the graph of 2 to the x. We're all familiar with the shape. If I want to plot the natural log of 2, log base 2 of x, then this is the inverse function to 2 to the x, okay? Logarithms and exponentiation, they're inverses, so you can expect this to be the inverse operation to this one. And to plot it, we know the usual trick. You can reflect it in y equals x. If I plot that, we can get a better idea of where the mirror line goes. That's y to the x. If we reflect all of these coordinates, then we can see how the log graph relates to the exponential graph. So let's type it in, log base 2 of x. We'll talk about it a little bit as well. And there it is, okay? So this slow climbing shape is the typical log graph shape, okay? Just as this upward climbing is the exponential shape, this is the logarithm shape. All right, so when you look at this curve, you're thinking of, right, what power of 2 is x? All right, so over here, this is when x is 1. Well, what power of 2 is 1? Well, that's 0. For this one here, x is 2. What power of 2 have we got? That's 2 to the 1 here. And then when we get to 4, this is 2 squared. So that's the height over there. So on the exponential curve, it grows very quickly. If you take a step to the right, your height is going to double. On the logarithm graph, it's the other way around, okay? So if I want to take a step upwards, you've got to go twice as far to the right, okay? And I can show you how this looks if I go to the right. It keeps growing slower and slower and slower, and it takes you much more of a distance to the right to move upwards by 1. Here we are, look, 64 for x. You can tell me what that is as the height. So what power of 2 is this? That's 2 to the 6. So there it is over there. All right, let's go back. So that's how they're linked. You've also got this asymptote as well. This is all your 2 to the negative powers over here. So if I go to a half, that's 2 to the minus 1. If I go to a quarter, that's 2 to the minus 2. And an eighth is 2 to the minus 3, and so on. It will go down there. Okay. Note as well, you can't plug in a negative or 0 for x. Okay, you can't plot on this left-hand side of the picture. Okay, it's only right-hand sides. And that's because exponentials can't be negative. All right, you can't have a power of something that makes a negative number. All right, so that's the basic graph. That's log base 2. Let's take them off and do base 10. So if we do y equals 10 to the x, that's going to be a lot steeper. If we do the log graph, log base 10 of x, there you go, same idea, okay, it's the same similarities, except this one's steeper, so this one's much shallower. Okay, and just so we can see it, let's do e to the x and natural log of x. There's the special one, that's the one that we most commonly use, e to the x, and then natural log of x, ln of x looks like that. Okay, so they're all the same pairing. Okay. So the property of log graphs that they'll share is this point down here. Okay, just as the exponential curves all go through 0, 1, all logs will go through 1, 0. Okay, and they'll have this asymptote down to there. Right, I think that's all I wanted to say about those. There's a short task on logarithms, and there's a little bit at the end on logarithmic graphs, so hopefully you can now do that.